A solution that provides the best of both worlds is called finger tables, where every node knows m other nodes in the ring, and the distance of the nodes that it knows increases exponentially. So for example, node 10 would maintain mappings for 10 plus 2 to the 0, 10 plus 2 to the 1, and so forth, where finger I points to the successor of n plus 2i. So finger 0 would point to the successor of 11, which is 32. Finger 1 would also point to 32, and so forth. Finger 5 would point to 43. Now every node knows its immediate successor. So what we want to do is find the predecessor for a particular ID and then ask for the successor of that ID. So let's suppose that node 10 wanted to look up a key corresponding to the ID of 42. It can use the finger tables to find the predecessor of that node, which in this case is 32. Its finger tables have the mapping of that node's location as well. It then can ask node 32 for its successor. At this point, we can move forward around the ring looking for the node whose successor's ID is bigger than the ID of the data, which in this case is node 43. Due to the structure of the finger table, these lookups require order of log n hops. This results in efficient lookups, order log n messages per lookup, and the size of the finger table is order of log n state per node. Another consideration that we have to take into account is what happens when nodes join and leave the network. When a new node joins, we first have to initialize the fingers of this new node. Then we must update the fingers of existing nodes so that they know that they can point to the node with the new ID. And finally, the third step is to transfer the keys from the successor to the new node. In this case, the key that we must transfer from the successor, 1, is the data with ID of 54. In this case, each node's successor is maintained, and the successor of any particular ID k is always responsible for k. A fallback for handling leaves is to ensure that any particular node not only keeps track of its own finger table, but also of the fingers of any successor, so that if a node should fail at any time, then the predecessor node in the ring also knows how to reach the nodes corresponding to the entries in the failed node's finger table.